Alright, so this is Module 1 D&E, and we're going to be doing option A today. So starting with the word problem that I created, it reads, Malachi has 37 gummy bears in his goodie bag. He gave away 19 gummy bears to his friend Josiah. How many gummy bears does Malachi have left in his goodie bag? And so first off, we're going to start by sort of decomposing this word problem and seeing what's most important in it. First of all, the important numbers are 37 and 19, and the important vocabulary here is those two words gave away. And so Malachi gave away 19 gummy bears. So that means we're going to be subtracting today. And we always want to remember that we need to take the small number from the big number when we're doing subtracting. So the algorithm is going to read 37 minus 19. And today we're going to be solving with the set model and the linear model. So let's go ahead and move on with that. Okie dokie. Using the set model, we are going to be working with our 10 frames today. And so let's go ahead and start by writing out the algorithm. So we have our algorithm here, 37 minus 19. We're going to be using the make 10 approach. And so let's go ahead and break down that 19 and decompose that 19 according to place value, all right? So we're going to break down that 19 into a 10 and a 9, as we can see here, okay? But I think we need to break down the 9 a little bit further because we cannot take the 9 from that 7. And so we have to do the ones place together, and so we're going to have to break down this 9 a little further. So to help us, let's go ahead and break it down into a 7. So what plus 7 adds to 9? So what two numbers, including 7, is going to give us a 9? And so we broke that down a little further, and we got a 7 and a 2. So we're going to have to break down this 19 into a 10, a 7, and a 2 using those 10 frames, okay? So we're going to start by filling our 10 frames with our blue counters in order to represent the number 37. Okay? And our students should be able to tell that filling an entire 10 frame means 10. And so since we have a 3 in our tens place for the number 37, we should have 3 full 10 frames. So we're going to have 3 full 10 frames. By the time I get done with this, might be a little while. But this is a really awesome tool so that our students are able to visualize the 10 frames and continue working on that subitizing skill so that they're able to recognize these numbers on a 10 frame. Almost there. So we've got our 3 full 10 frames, and then we've got 7 left here. So recognizing that that's what a 7 looks like on a 10 frame is really a really important skill as well. So we're going to begin by doing our decomposing our 19 but on the 10 frame. So let's go ahead and take off an entire 10 frame and let's replace it with our green counters so that we are better able to visualize the subtracting number. Okay, so we've got a full 10 frame here. All right, and so that's 10. We still have a 7 and a 2 that we need to take away based off of our algorithm and decomposing the number 19. So lucky for us here, we've got a 7 to completely take off. And so we are going to replace it with the green counters once again so that we are able to visualize this just a little bit clearer. And then we still have that 2 left in order to make 19. So I'm going to take away these 2, and we're going to finish this off with the last 2 green counters. So as we can see here, we have 37 total, as we can see. And then the green counters are standing for 19, our subtracting number. And so once we take away all of the green, we'll be left with our solution. So let's go ahead and do that. All the green are off. And we are left with 18, as we can see. We have 1 full 10 frame and an 8 on a 10 frame. So that's how we solved 37 minus 19 equals 18 using the set model 10 frames. Okay, so we're going to go ahead and start our subtraction problem using the linear model. And so our linear model is going to be our number line where we measure the distance in between the numbers. Okay, so for subtraction particularly, we're asking ourselves the question, how far apart are these two numbers? Okay, so let's go ahead and start. We have each marker is a 10, and so each little line in between is standing for a 1. So it's going to be 21, 22, 23, 24, 25, and so on, okay? But for subtraction, we always want to start at the end of our number line and work backwards. So we're going to be backwards counting today, skip counting, and using some addition strategies that we have learned previously. So let's go ahead and get started by writing our algorithm at the top. 37 minus 19, okay? Equals what? I'm trying to find our answer here. So we're going to go with, go ahead and start 37, right? And we're going to go ahead and start here. I want us to go ahead and use the make 10 approach here as well. So we're going to go all the way back to our number 30 because that is a 10, and it is also just a friendlier number to use. So we're going to go ahead and put subtract 7 because there's 7 in between these two numbers, right? 7 is our distance in between these numbers, so minus 7. Then, looks like we still have a 10 left, right? We haven't taken away a 10, so we can still jump back another 10. So we're going to go ahead and do that. Minus 10. Okay, so we've got 2 jumps here, adding up to a total of 17. So what number do we have to add to 17 to get to 19? Yeah, 2 exactly. So 1, 2. We're going to jump back 2 more. All right, and we're going to add these together and use our addition strategies to make sure that we subtracted 19 from 37, okay? So we've got 10 plus 7 is 17, 18, 19. So indeed we did subtract the correct number from 37. We did backwards count correctly, and it looks like our solution here is going to be 18, which is the exact same answer we got using the set model. So 18 here is our answer using the linear model and the make 10 approach, backwards counting, skip counting, and some addition strategies. So we got the same answer using the linear model.